Hello sir, my name is Bornali Dash. I am from third year EC department. Today I will discuss about pulse code modulation. What is pulse code modulation? Pulse code modulation is used to convert analog signal into digital data. It passes through some process like sampling, quantization and encoding. In PCM, first we do sampling to convert analog signal into discrete signal. Here we show the picture how we get analog signal to discrete signal by sampling method, and after that we do quantization to convert discrete signal into digital data, and then by encoding we get the digital data which is a binary number like 0 1. Now the process of sampling. First, analog signal is sampled after every TS interval of time. Analog signal, by sampling method we get sampled output, which is convert the analog signal into discrete signal. So sampling frequency is Fs equals to 1 by Ts. Minimum sampling frequency Fs, which is greater than equals to 2 FM. Here FM means message signal. Fs is equal to 2 FM is even referred as Nyquist rate. Quantization of pulse code modulation. The process of measuring numerical values of the samples and giving them a table value in a suitable scale. Amplitude is varying from 0 to 1 for 3 bits per sample, like our bits are 3. So our samples number will be 2 to the power n or 8 samples. Quantization means it is a approximated value or a round of value. It's rounded a value of signal. Voltage difference in between samples equals to delta V by L. Here delta V means bit rate by the length. L means samples, number of samples. The finite number of amplitude intervals is called quantization interval. Difference between sampled output and quantized output is quantized distortion. Sample output is equals to 0.129 volt and quantization output equals to 0.126 volt. So the error is 0.19 volt minus 0.26 volt is equal to 0.004 volt. Now we discuss about the bitrate and bandwidth of pulse code modulation. Let the quantizer use V number of binary digit is represent each label. Then the number of label that V can be represented by V digit will be Q equals to 2 to the power V. Here Q is the length, total number of digital labels. Here Q is denoted for labels. The number of labels is denoted by Q. We know that number of samples per second, which we are denoted by Fs, and the number of beats per second, which is the multiplication of the number of binary digit and the number of sample per seconds, or it is V into Fs. Number of beats per second is also called signaling rate, which is denoted by R. And the bandwidth of PCM. Bandwidth of PCM, the formula is half into VFS, or less than equal to half of V into 2FM. Before we know that VFS equals to 2FM. So the bandwidth is less than equal to VFM. Now we discuss about PCM of speech signals. Most of the significant spectral component of speech signals are contained in the range of 300 to 3400 Hz. Nyquist rate of the signal 2 into 3400 equals to 6.8 kHz. Practical sampling rate f of s equals to 8 kHz and number of quantized level equals to 256, where n equals to 8 log 2 base 256. Now we discuss about PCM receiver, which is regenerated the message signal. First, PCM plus noise signal passes through regenerated circuit, and in regenerated circuit we give pulse generator. After that we get pure PCM of output, and then the output of pure PCM passes through the serial to parallel converter which is connected to pulse generator, and this converter is convert digital to analog converter. We get analog signal, and the analog signal passes through the low pass filter. We get the output of message signal. This is the receiver of PCM. Now, quantization noise. Because of quantization, inherent errors are introduced in the signal. This error is called quantization error. Here we discuss the formula where x mu nts minus x into nts, where xq nts is quantized sample and minus x nts is sample, number of samples, number of quantization level q, then step size delta equals to 2xm by q, where xm is the maximum amplitude, and our maximum quantization error is mod of delta by 2. The variance of noise, we get by derivation delta square by 12, and by normalized power, and we get normalized power considering R equals to 1 ohm, we get the noise power delta square by 12, and signal to quantization noise power ratio SQNR equals to signal power to quantization noise power, which is P by delta square by 12, and by normalized input voltage within plus minus 1 volt, we get SQNR equals to 3P to the power 2V, and by dV we get SQNR in dV is less than equals to 4.8 plus 6 volt. Now we discuss about advantages, disadvantages and application. Advantages of PCM: it is uniform transmission quality, integrated digital network, good performance over poor transmission path. And the disadvantage are PCM: large bandwidth requires for transmission, noise and crosstalk levels low, but attenuation will increase. And application of PCM is in compact discs, digital telephone, digital audio application. And lastly, we discuss an example of PCM. Here we give an example. A television signal with a bandwidth of 4.2 MHz is transmitted using binary PCM. The number of quantization levels in is 512. So calculate code word length and final bit rate, transmission bandwidth and output signal to quantization noise ratio. So here given the bandwidth is equals to 4.2 megahertz and quantization level is 512. So code word length, by using the formula of q equals to 2 to the power v, we get the code word length v equals to 9, and the final bit rate by using the formula v into fs, we get 75.6 megahertz, and transmission bandwidth by formula half of v into fs, we get 37.8 megahertz, and lastly the output signal to quantization noise ratio by the formula of dB of SQNR 6 plus 1.8, we get it 7.8. Thank you.